Good day. In this lecture video, I'm going to discuss the solution to sample problem number 3 in lecture 4 about EMF, internal resistance, and terminal voltage. Okay. So a voltmeter connected across the terminals of battery gives a reading of 12 volts. The external resistance of 10 ohms is connected across its terminals. The voltmeter gives a new reading of 11.5 volts. So what is the internal resistance of the battery? So first, we list down the given quantities. Okay. So we have the epsilon to be 12 volts, external resistance capital R to be 10 ohms, and the terminal voltage to be 11.5 volts. So we can draw simple sketch for the two cases. Okay. And we let this symbol to be a voltmeter. Okay. And then here we draw the model of practical battery in which we have an EMF in series with a small internal resistance. And then we label the voltage readings from the voltmeter. Okay. Next, our target variable is the internal resistance, small r. Okay. So maybe at this point, you may be wondering on how did we determine that the given 12 volts is the EMF and 11.5 volts is the terminal voltage. Okay. So we need to refresh and review ourselves the relevant concepts required to solve this problem. Recall, so the use of a voltmeter. So a voltmeter is a measuring instrument. It is connected across the terminals in any part of the circuit we wish to measure the voltage. Okay, so in this case, we connect the voltmeter at these 2 points A and B to measure the potential difference between points A and B. Okay? So since the purpose of the voltmeter is just to measure the voltage between 2 points or the potential difference between 2 points, ideally it must have infinite resistance. Okay? Infinite resistance because by physically connecting this voltmeter, we don't want the other voltages and currents in other parts of the circuit to be altered just because we connect the voltmeter in the circuit. So if the ideal voltmeter has an infinite resistance, that means it won't draw any current because infinite resistance is identical to an open circuit. In open circuit, no current will flow. Okay? Therefore, recall in our discussion, the terminal voltage of a battery with a small internal resistance in series can have three possible values. So, in the first case, when only a voltmeter is connected across the battery, so it is open circuit case or the first case. So the terminal voltage will be equal to the EMF because no current will flow. Okay. And then the second case, we connected an external resistance, and since the resistor is not capable of supplying power, okay, then the battery must supply power to the external resistance. So in other words, the battery is now supplying power to the external resistance, so the current must come out of the positive terminal of the battery. Okay. Therefore, the reading of 11.5 volts is our terminal voltage, and the 12 volt reading is our EMF. Okay. So with that, we can apply the following formulas. The terminal voltage with the external resistance connected is equal to the EMF minus the current times the internal resistance. And then, so the current is equal to the EMF divided by the sum of the resistances, small r plus capital R. Okay? Now we execute our solution. So for the first expression, we substitute I here to here. Okay? Again, our goal here is to solve for small r. The current I is not given in the circuit, so we try to eliminate the symbol letter I from our computations. Okay? So as to avoid solving for the current first and then solving for the internal resistance. Therefore, we substitute the second equation to the first equation. Okay? And then we perform algebraic manipulations to obtain a symbolic expression for small r in terms of the other quantities. So as a result, we obtain this expression for small r. And then we now substitute the values. Okay? So R is 10 ohms. Okay? Then here the difference between the EMF and the terminal voltage divided by the terminal voltage. So again, we don't need to perform further unit conversions because the volts will cancel out, leaving us with small r with the unit of ohms. Okay? So the internal resistance turned out to be 0.4048 ohms. Okay? Again, as always, before ending this lecture video, okay, try to discuss some relevant concepts about our result. Okay? So, with current flowing to the source, okay, in the second case, since we connect an external resistance, current will begin to flow out of the positive terminal of the battery. So in this case, we expect that the terminal voltage will be less than the EMF, which is the case. Okay? And then, so if you want the terminal voltage to be close to the value of the EMF, then we either reduce the size of the internal resistance. So in other words, how do we do that? So either we choose different type of battery or we can connect different cells in parallel. Okay, so that with the latter case being the topic of lecture 5. Okay, the smaller r. So we can connect different cells in parallel to reduce the internal resistance, or we can simply use a different type of battery, or we can increase r. Okay, so increase the external resistance such that terminal voltage will be closer to the EMF. So the extreme case is when R is equal to infinity, just like the first case, we have the EMF equal to the terminal voltage. However, in that case, no current will flow. Okay? So in this case, no current will flow to the circuit. Okay? So this ends sample problem number 3.